Hey folks, welcome to my channel Number Pen. So we have the problem on our screen. Find the derivative of the following function with respect to the corresponding independent variable x. F of x equals sine x plus cos x, right? So we've been asked to find f dashed of x. So let's write that particular expression, and looks like it is a sum of two differentiable functions, right? So if I may call those functions as u and v, let's write down what is our u and v, right? So my u of x is nothing but sine x, right? And my v of x is nothing but cos x, right? Now we've been asked to find what is f dashed of x, which is nothing but from the sum rule of differentiation. I have this as f dashed of x equals u dashed plus v dashed. Okay, so we know our u dashed, and if you have not taken a look at my previous video where we solved dy dx of sine x as a part of solving the derivative of the function x minus 3 sine x, I request you to take a look at it, that how is the derivative of sine x derived from first principles. And it's important that you remember dy dx of sine x equals cos x, right? And now we've been left with v dashed, which is cos x. So let's use this problem to understand how do we derive dy dx of cos x using first principles, right? So I'm going to call my v dashed using first principles. So let's write that out. Limit h tending to 0, v of x plus h minus v of x divided by h, right? And what is that? V of x plus h is nothing but cos of x plus h, right? Minus cos of x, right? Which is my v of x. And then I can further write my cos of x plus h as, using the trigonometric formula, it is nothing but cos x cos h minus cos h minus sin x sin h, right? And then I have my cos x still, and then I have my h, right? So now we have cos x cos h minus sin x sin h minus cos x divided by h, right? So I'm going to combine the cos x terms. So which means, let me highlight them in green. I'm going to combine the cos x terms, and then I'm going to rewrite the expression in the next line. So this expression can be written like this, right? My cos x is a common factor and it's independent of h. So I'm going to pull that out, right? And then I have this entire expression cos h minus 1 divided by h, right? So cos h minus 1 divided by h, right? So let's bracket this, right? And then I have another expression which is minus of sin x. And remember, folks, my sin x is independent of h, so I can pull that out as well. And then my limit h tending to 0, I have an expression which is sin h by h, right? So let's bracket that as well. So now we have two expressions which are quite familiar to us. The limit of this expression, which is sin h by h tending to 0, is 1. And the limit of this expression, cos h minus 1 divided by h, is 0. And if you haven't taken a look at my previous videos, you will see how I have solved for this, right? The limit of this particular expression cos h minus 1 divided by h is also 0, right? So we don't have to worry about the first part of the expression. And when I rewrite this, my first part of the expression becomes 0 because my limit h tending to 0 cos h minus 1 by h is 0. And request you to take a look at my earlier video where I have solved for this, and I will put a link to that particular video in the description. And I have a minus sine x into 1, right? Because my limit h tending to 0 sine h by h equals 1. So sine x into 1. So the derivative of cos x using first principles is minus sine x, right? Now let's go back to our f dashed of x. And what is my f dashed of x is u dashed plus v dashed using some rule of differentiation. So I can rewrite this as sine x is nothing but cos x because d by dx of sine x is cos x, and d by dx of cos x is nothing but minus sine x. So the answer for this particular problem is cos x minus sine x. So d by dx of sine x plus cos x is cos x minus sine x, right? So I hope you found this content useful. Please do subscribe to my channel and support. Thank you.